Hello everybody, this is Mr. Mercier from the math department, hopefully to teach you about a little bit inverse trig today. Now, we're going to be using a lot of the same stuff we've been working on the last couple weeks, the SOHCAHTOA. The only thing that's going to be different about the inverse trig is now we're trying to find the angle. Before you had an angle on the side and you used all those similar triangles to find out what the missing sides were. Now we're just going to be finding a missing angle. So let's look at an example. Now, let's say I want to solve for this angle x. Okay, so first thing I got to think about is of SOHCAHTOA, I got to think about what sides I have. So the 3 in reference to that angle x is going to be called the adjacent leg, and the 7 is going to be the hypotenuse. So we're going to end up using cosine for this one. Okay, so I'm going to set it up the same way where I'm going cosine x equals the adjacent over the hypotenuse, and then I'm going to fill in my sides. And the goal is to solve for that x, that angle. So what we're going to do is we're going to use something down here called the inverse cosine. Okay, and it's not necessarily a cosine raised to the -1, it's just the way that it's written. So I'm going to go to a calculator. I'm going to figure out what the inverse cosine of 3/7 is. Okay, so I'm going to go to my Desmos calculator, and I'm going to do the inverse cosine. The way that you're going to get to that is going to be right down here. I'm going to hit the functions, and I have all these things here. So I'm going to do the inverse cosine. I'm going to go 3/7, and I'm going to get a number right there. Now, that number is not the actual correct answer because I am not in degree mode. Okay, there's other ways of measuring degrees called radians, and right now I'm in radian mode. So I need to switch this over to degree mode. You'll learn a lot more about radians in pre-calculus. Basically, it's just another way of measuring an angle, same way that you measure in inches and centimeters. So I'm going to do the same thing. I'm going to go the inverse cosine of 3/7, and I'm going to get that angle is 64 degrees. Now, if you don't want to use Desmos, say you wanted to use a regular calculator, again, you should make sure that you are in degree mode. Okay, and it looks like I am. Okay, and then you're going to do the inverse cosine. Now, the inverse cosine is always written right above the cosine. So I'm going to go second cosine, and I'm going to do 3 divided by 7. And I get the 64 degrees also doing it that way. Okay, now let's look at another example. So again, you got to figure out, am I going to use sine, cosine, or tangent? So right now, the 11 is going to be the opposite, right, because it's opposite of it, and the 25 is going to be the hypotenuse. So it's going to be O and H. That means I'm going to use the sine function. So it's going to be the sine of x equals the opposite, 11 over 25. Again, we're going to go to our calculator to figure out what is the inverse sine of 11 over 25. And it's going to be 26 degrees. So that tells me that this angle right here is 26 degrees. Now let's look at another example. So if I look at right here, I'm trying to find angle x. The side length here of 1 would be the adjacent, and opposite of x is 2. So I have the opposite and the adjacent. So that's going to be TOA of SOHCAHTOA. So we're going to set up the same way where I'm going to find the tangent of that angle equals the opposite over the adjacent. So 2/1. And then I am going to just take the inverse tangent on my calculator, and it's going to end up being 63.43 degrees. Okay, thanks for listening. I hope you guys learned something.